Hello, myself Dr. J D Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about interconnection structures. At the end of this video, the student will gain knowledge regarding what are the interconnection structures that are used in the multiprocessor systems, what are the various types of interconnection structure and features of each type. This topic learning outcome will map the course outcome of summarize the concept of pipelining and inter-process communication for advanced process design. The topics that are discussed in this video are introduction, the types of the interconnection structures, time-shared common bus, multi-port memory, crossbar switch, multi-stage switching network, hypercube system. So, a multiprocessor systems are generally nowadays used. Why? Because most of the applications are engineering and scientific applications, and the recent advancement in the computer field can support a large volume of data processing, and most of the applications are computational incentive applications. To support this, the hardware advancements can be required so that the multiprocessor systems are used nowadays. So a multiprocessor system in a single computer that has multiple processors. So it is possible for the processor to communicate among these with the help of message passing or with the help of shared memory techniques. So here these processors can be communicated to process and to provide the computational incentive or large volume processing or distributed application development. So the communication between these processors can take place by sending messages from one processor to another or by sharing a common memory. So two techniques are used between the processor to share the common data, that is message passing technique or shared memory technique. So most of the multiprocessor systems are multiprocessor systems can support the parallel processing. So the task can be divided into segments. Each segment can be executed in a specialized registers in parallel with the other subtask of the process. So the multiprocessor systems are the parallel systems, and they can use it to support concurrent execution of multiple tasks at a single point of time. So thereby it increases the performance of the system. So these multiprocessor systems can working in parallel to share the computer clock, memory, bus, peripheral, etc. So the processors can be linked together to share the common resources of clock, memory, bus, peripheral devices. But these processors can be communicated with the help of message passing or the shared memory technique. So here this is the general architecture of the multiprocessor. Here 8086 is the main processor and the co-processor is the 8087. Both are connected and they are shared with the common clock of the computer, common bus control logic and arbitration logic, common memory and I/O. So more than one processor are employed and can be shared the system clock, bus logic, memory and I/O. So this is the general architecture of the multiprocessor systems. So the multiprocessor system can have the advantages of more reliability. So multiprocessor systems are more reliable systems. Why? Because if one processor is failure, the system should not shut down or crash. So the load of that processor can be shared by another processor so that the ability to continue working despite of hardware failure. So this is known as the graceful degradation. And enhanced throughput, the task can be executed concurrently. Either the arithmetic task or the instruction steps or instruction cycle steps can also be executed in parallel, thereby enhancing the throughput. That is, the number of processes that can be executed per a unit of time can be increased. Third one is more economical systems. So here most of the processors has to be connected and can parallelly execute, can share the common clock, memory, IO. So that these processors can increase the performance with little amount of hardware. So these are the more economic systems. The disadvantage is special care required for the arbitration process. Communication, committed operating system has to be needed to control and monitor the multiple processes, and large main memory can be required to accommodate each processor task. So these are the disadvantages of the multiprocessor systems. What are the characteristic of multiprocessor system is, the multiprocessor systems is interconnection of two or more CPUs. So multiple CPUs can be employed in the multiprocessor systems. The term processor is a multiprocessor system mean the central processing unit. Either it can be the CPU or the input-output processor. So those can be employed more than one processor in the multiprocessor system. These processor can be either the CPU or the IOP. Multiprocessors are classified as multiple instruction stream, multiple data stream computers. So they Flyin has classified the parallel processing systems. In that category, MIMD category of systems comes under the multiprocessor system, which can have multiple instruction stream and multiple data stream. And these multiprocessor system can support the parallel computing. So simultaneous or concurrent execution of tasks can be performed in the multiprocessor system. Next, the multiprocessor system can support the distributed computing. So here the processors should not support only the centrally located peripherals or can execute central task, but they can support geographically scattered tasks that are connected via the network. Thereby, these multiprocessor systems can support distributed computing. And the multiprocessor system can support the supercomputing. So the fastest processing or fastest processing of large volume of data can be done with the help of supercomputing. Thereby the throughput can be increased. So multiprocessor systems can support the supercomputing. And multiprocessor system has a characteristic of vector computing, so which involves the vector processors can segregate the major computational task into small parts or the steps, and these steps can be carried out or performed in a stream of operands. So thereby the multiprocessor system can support the vector computing. How the layout of the multiprocessor architecture is, here the core 1, core 2, core 3, core 4, 4 cores are present, and each processor can have individual dedicated memory and can be connected to a shared memory to share the common resources, and it can be connected to the bus interface to the off-chip components. So this is the internal layout, the circuit layout of the multi-core processor. This is the one core and this is the second core. So how these multiprocessors can be connected. So that is taken care with the help of interconnection structures. The interconnection between the components of multiprocessor system can have different physical configuration. Okay, so it can use different topologies for interconnection of various components of multiple processors. So here the major decisions can be, design issues can be number of transfer paths that are available between processor and memory in a shared memory system. So here multiprocessor system can have the dedicated individual memory, and to share the common resources, shared memory is there. How these cores can be connected with the memory to share the common data. How many number of paths can be, transfer paths that are connected between the processor and memory in a shared memory system is the major design issue. And the second issue is among processing elements in a loosely coupled systems. So that loosely coupled systems can be used to transfer the messages and to share the data and common resources between the processors. So these design decisions can be considered during the interconnection structures, which are majorly used to connect the various components of multiple processor system. And variety of interconnection structures are available. They are time shared common bus, multi-port memory, crossbar switch, multi-stage switching network, hypercube. These are the variety of interconnection structures. What is a time shared common bus system? So all processors and memory are connected to a common bus. As the name implies, time shared common bus. All processors and memory are connected to a common bus. So depending upon the request raised from the devices, the time can be allotted for the devices to connect to the bus and can use the resources. So memory access is fairly uniform but not very scalable. So here what is the time slot that is allotted? So for that only the device can avail the service and the remaining devices can be in a waiting state. So a collection of signal lines that carry module to module communication. So here the buses can share the common bus, the memory and the processors can share the common bus, but in a time shared fashion. That time can be the time sharing can be in a uniform manner, but it cannot support the scalability. So data highways connecting several digital system elements and the operations of the buses. So this is the architecture of time shared common bus architecture. So here this is the memory unit and here multiple processors and this is the CPUs. The processor can be either the CPU or the IOP. So these can be connected via a common bus. So the device can has to share the time slot that is fair share allocated to the particular CPU for processing. So in this way the devices can communicate and share the common memory. How the bus structure in these cases of time shared common bus. So here the system bus structure can be system bus controller, and via the local bus the CPUs can be connected. The CPU can connected its dedicated memory, local memory and IOP via the local bus, and it can connect to the system bus controller to share the common shared memory. So this is the single CPU which is used to connect the local memory, IOP, and can be connected to the system bus control to share the common memory. So this is the second CPU and which is used to connect the IOP local memory with the local bus and can use the system bus controller to share the common memory. So this is the one more processor. So in this way the bus architecture can be employed in case of time shared common bus interconnection structure. So each local bus may be connected to a CPU, an IOP or any combination of processors. But a system bus controller links each local bus to a common bus. So here local bus is used for particular processor dedicatedly to connect the IOP and memory of that particular processor. But the system bus communication pathway can be used to share the common memory between multiple processors. The IO devices connected to the local IOP as well as the local memory are available to the local processor itself. The memory connected to the common system bus is shared by all the processors. If an IOP is connected directly to the system bus, the IO devices attached can be made available to the all processors. If the input-output devices and shared memory can be common to all processors, then these can be connected to the system bus. The local bus is used particularly to connect the resources for the local processor itself. What are the disadvantages of this time shared common bus system? So only one processor can communicate with the memory, other processors at a given time. So here it is a time shared common bus. If the device can have a fair share of time for communication and connection with the resources, then only the communication can be possible and sharing of resources can be possible for that CPU. The other CPUs can have to be remain in the waiting state. So this is the major disadvantage of time shared common bus interconnection. As a consequence, the total overall transfer rate within the system is limited by the speed of the single path. So the speed can be reduced. Why? Because the common path, single path is used for communication between the various processors. So these are the disadvantages of time shared common bus interconnection structure. The second interconnection structure is multi-port memory structure. So it is having multiple memory modules. Each port serves as a CPU. Here multiple ports are employed. The port can be the CPU and various memory modules are connected to these ports. Memory module control logic can be used. Each memory module has control logic in order to arbitrate which module to be involved in the communication and resolve memory module conflicts, fixed priority among the CPUs. So the memory module can have a fixed priority so that the conflict among the communication of memory modules can be resolved. Multi-port memory is a multiple processor memory that helps in providing more than one access port to separate processors or to separate parts of one processor. So here this is the multi-port architecture. So these ports are the CPUs. Multiple CPUs can be connected to the multiple memory modules. So here this is the interconnection structure. Via this communication path, the CPU 1 can communicate with the memory module 1. Which module, the module arbitration can be depending upon the priority, fixed priority that is done by the CPU. So a multi-port memory system uses separate buses. As in the case of time shared one, only one single bus is used. But here separate buses between each CPU and each memory module. So if you look into the architecture, the CPU 1 can have a separate communication path. CPU 2 with memory module 1 can have a separate communication path. So here the multi-port memory architecture can employ a separate buses for each memory module and CPU communication. Each processor bus is linked to each memory module. A processor bus includes three components as an address, information and control lines. So for communication, the address can be required at which location of memory module the information can be transferred, what information can be transferred, and whether it is a read operation or the write operation. These components are required to connect with the memory. So this is the general architecture of the multi-port memory. So here the ports are the CPUs and various memory modules are employed, and each module has to be connected with each processor via a separate bus for communication. What are the advantages of this multi-port memory module architecture? So the high transfer rate can be achieved because of multiple communication paths are employed. The disadvantage is it requires expensive memory modules. So memory control logic can require here more attention, and more communication paths has to be connected. So this is the disadvantage of the multi-port memory architecture. Next, third interconnection structure is the crossbar switch. So here in the crossbar switch, each switch points has a control logic to set up the transfer path between a processor and the memory. So here switching logic has to be employed to define or to set up the communication path between the processor and the memory. So it also resolves multiple requests for accessing to the same memory on the predetermined priority basis. No fixed priority is there. The switching logic can determine the communication path between the processor and the memory module in case of crossbar switch. Though this organization supports simultaneous transfer from all memory modules because there is a separate path associated with each module. So here also no common bus, separate communication path can be established between the processor and memory that can be depending upon the switching logic. The hardware required to implement the switch can become quite large and complex. So the design of the switching logic can be a complex task in case of crossbar switch. How this architecture can be? So various memory modules are employed and multiple processors are connected to the memory module with a switch. So the switching logic can use it to decide the communication path between the processor and memory. So no common bus can be there. Separate communication path can be established for communication of each processor with the each memory unit, and no fixed priority can be defined for the processors for communication. The switching logic itself establishes the communication path between the processor and the memory module. But this design of switching logic is a complex task. So how this crossbar switch, what is the switching logic? So the crossbar switch can use the multiplexers for the switching logic, and it has to decide the address of the memory location, the information, the control signals, and which memory module can be enabled is decided by the switching logic with the help of the multiplexers. And data can be traversed to and from various CPUs that are connected to perform the read operation or the write operation. So this is the switching logic that can be employed at the intersection of memory module and each CPU communication path. So the block diagram contains multiplexers which is used to specify the location, address, the information as well as the control signals to communicate the processor with the memory. So arbitration logic establish priority levels to select one CPU. So here this arbitration logic has to select one CPU for the communication. The multiplexers can handled by binary code which is produced by the priority encoder. So this is the switching logic that can be employed at each crossbar switch. What are the advantages and disadvantages of this interconnection structure? The advantage is supports simultaneous transfers from all memory modules. So parallel transmission of resource sharing and data processing can be possible, but the disadvantage is require the switching logic, which is a large and complex and tedious task. Next interconnection structure is multi-stage switching network. So here in this interconnection structure, the basic element of multi-stage network is a 2 input, 2 output interchange switch. So a switch can be employed which can receive 2 inputs and produces 2 outputs. So the arbitration logic has to be established with the help of this switch. So the 2x2 switch has 2 inputs labeled A and B and 2 outputs labeled 0 and 1. The output can be labeled as 0 and 1, input can be labeled as A and B. There are control signals related to the switch and the control signals start interconnection between the input and output terminal. So this is the structure of the multi-stage switching network. So it is a 2x2 switch which is having 2 inputs A and B and 2 outputs 0 and 1. So the switching logic established here can be used to interconnect the processor with the memory module. So these are the multiple switches are employed in the network, thereby they name multi-stage switching network. So the switch can join input A to either of the output. The terminal B of the switch facilitates similarly. So the switch can also arbitrate between conflicting requests. It is possible to start a multi-stage network to control the communication between multiple resources and destinations. So how they are connected, depending upon that the output can be activated. A is connected directly to the output 0, 0 can be the output, and A is connected to the 1. So here 2 possibilities of connection of input A to 0 and 1. And similarly, in the likewise, the B also is a possibility to connect to the 0 and it can be connect to the 1. So depending upon this connection, the arbitration logic can be established so that the processor can be connected to the memory module. So here it is a binary tree with 2x2 switching network. So 2 input it has to be taken and it is connected to the if it all 1 logic and it can produce with the 0 1. Next it is processed to 1 1 0 1. So the combination of with these network multiple switches that can be combined here with a combination, it can produce if it follows the path of this connection, then it can produce the arbitration of 0 0 0. So that CPU 0 can be selected for communication path for the processor 1 to the memory module. And if it all follows this arbitration, it has to produce 0 1 0. So like that, the 2x2 switch can be used to provide the arbitration logic. So the two processors P1, P2 are to be connected through switches to 8 memory modules labeled. So the processors can connect it to the memory modules depending upon the multi-stage switching connection, which can generate the arbitration logic. So the direction beginning from source to destination is decided from the binary bits of the destination number. So here the destination can be either 0 or 1, and the processor can connect to the binary destination either 0 or 1 in order to produce the required arbitration logic to activate the concerned memory module in case of multi-stage switching network. And this is the 8x8 omega switching network. So the stages can be connected with 8x8 switches in order to produce the binary combinations to connect to the concerned memory modules. So in a tightly coupled multiprocess, this 8x8 omega switching network can be used so that the memory can be connected tightly to that particular processor for sharing the data. So the address has to be transferred via the communication path. Address, information and control signals can be traversed. In a loosely coupled multiprocessor, both the source and destination are processing elements. So in 8x8 omega switching network generally used in a tightly coupled multiprocessor systems. The next interconnection structure is the hypercube. The hypercube is the binary n-cube multiprocessor. So if it all n is the processors, 2n is the interconnection structure can be used with the help of cube. So each processor forms a node of the cube and it contains not only CPU but also local memory or I/O interface. Each processor address differs from that of its neighbors exactly by 1 bit position. So if it all n processors are there, 1 processor, 1 cube. If it are 2 cubes are there, this is the structure. And 3 processors are there, this is the cubic structure and with the binary arbitration bits. So how the routing process can be established in this hypercube? So routing messages through an n-cube structure may take from 1 to n links from a source node to the destination node. So the routing path can be established from a source to n number of multiple nodes of the cube. A routing procedure can be developed with the help of exclusive OR gate. Generally, the shortest distance path can be selected for more efficient communication between the processor and the memory. And these are the various interconnection structures. So in this video, we discussed about what is the multiprocessor, how these multiprocessors can connect to various multiple memory modules with a variety of interconnection structure, and what are the advantages and disadvantages of each structure is discussed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.